All right, thanks everybody, and welcome to a event by IEEE Queensland in association with IBM LinuxONE. The session today is an overview of the blockchain landscape from the IBM technical lead, Anand Subramanian, who is the technical leader for IBM LinuxONE, which is confidential computing and secure data serving in the Australia New Zealand region. So firstly, thanks very much everyone for joining, and I will hand over to Anand to introduce and to kick off.
Thank you. So thanks everyone for attending. I know it's 6 p.m. On a Thursday, so the effort is appreciated. As Malcolm said, my role is that of a technical leader here, specifically in what is loosely termed confidential computing. I will cover what that means from an IBM perspective. And I wanted to run through our perspective of what blockchain is and what the blockchain landscape sort of looks like. But we'll start with some definitions around what they are, and then go into more about what IBM is doing in that space from a IBM systems perspective. IBM does have multiple approaches in what they do. I come from the systems part of the organization, but we do have things like consulting and cloud and so forth. I kind of straddle a combination of all of those and work with startups and existing established institutions, whether financial services, whether different industries. And my aim is to leverage the best of IBM's technology and capabilities to deliver what is a useful outcome for the users and the clients. And specifically in this space, we will cover blockchain and some of the platform and processed capabilities that IBM brings to bear on blockchain, and how to develop that for both public but also private blockchain and enterprise blockchain capabilities. Okay. What we'll cover today, as I said, loosely, we'll start with some one-on-ones, so just general, what is blockchain, what is Hyperledger, what is Hyperledger Fabric? And then I want to kind of pivot towards what we see are key requirements to develop or what is potentially stopping, the better adoption of blockchain and Hyperledger and so forth in different industries. And that's specifically around trust and what we are doing from an IBM perspective on zero trust. And trusted computing in general, and how we then make sure that what is secure image build and hyperprotect, how those particular technologies and capabilities address those zero trust and trusted computing needs. And lastly, I want to kind of cover off what all of that is built on, and that is built on our hardware security module. And I'm going to give a very brief look at what we're doing in that, and there's a lot of new innovation in that space I thought would be useful. At the end of that session, there should be sufficient time for some Q&A. So while we go through these decks, please jot down in chat any questions that you might have that you want to raise, and then we will come back to them at the end. If it's anything burning, then please put your hand up or something, and then we can try and address it straight away. Feel free to interrupt me, Mr. Host, and we'll do what we need to do there. Let's start with the most usual misconceptions that we see about blockchain, right? So we start with the understanding, or certainly the belief, that Bitcoin and cryptocurrencies is what blockchain is. That is certainly not true. And on the back of that, obviously the most recent fad is around NFTs, or non-fungible tokens. And so that therefore must mean blockchain. So there's a lot of sort of confusion. So those usual ones are what I've listed there, just a few common ones that I hear about in general when I talk to clients or people who are starting to look at blockchain. So that is also not, tokens are also not specifically anything to do, that is to say, they don't define what blockchain is. They may leverage blockchain, all of these capabilities, all of these things, but they don't necessarily define what blockchain is. I will not be spending a lot of time on what those cryptocurrencies are, what are tokens and fungible, non-fungible. That we will do as a different session further down the track when we do more of a deep dive on specific things. But so just a reference to it is that is not what blockchain is. A type of federated database is another one we normally hear, because obviously blockchain is distributed. And so there's a general understanding that, wait, hang on, we've been doing that through federated databases for a long time. And the reality is that is not also correct. It may have roots there in terms of how we do distributed computing, but it is not what defines a blockchain. It is only used in financial services. Now that is a yes and no. It is certainly something that where it all started, certainly, especially when it comes to distributed ledgers. The most immediate need was in financial services, but it is not not the only place where blockchain is of relevance. And lastly, does it mean that I need a wallet, or is a digital wallet? So when people talk about digital wallets to store Bitcoins and stuff, is that what blockchain is? Again, the answer is no. So what is blockchain? Blockchain basically lets you build a decentralized network of whether it's for business, whether it's for personal use, what we call public blockchains for specific transactions, so participants to share or move, digital currencies around. That is one option. But there are also things like how to manage identity between independent participants in a way that can be fully trusted. So blockchain is all about a distributed network, but it is a business network of some sort that says we have participants with identities, and there are assets that need to be moved around, and there are transactions that will describe how those assets are exchanged. And there will be some sort of digital contract underneath it that will underpin those transactions. And all of those will be logged in a ledger. And those ledgers can be distributed, but they don't always have to be. That's an important distinction, and it's an important one to remember, because not always is a Hyperledger, for instance, or a ledger in general, where transactions are recorded actually shared or should be shared, as long as there is a log of those transactions, and that can be immutable. So that is what blockchain is. So moving on to what Hyperledger and Hyperledger Fabric is. Hyperledger is an open source community built set of projects. It's actually more than one type of thing. But it's a set of frameworks, and it develops through the Linux Foundation and has contributors from different participants. IBM is one of the biggest contributors into Hyperledger Fabric and Hyperledger in general, and the Linux Foundation as well. And it is intended to streamline building blockchains, whether they're for public blockchain use or for private blockchain networks. And private can be a enterprise or non-enterprise sort of, shall we say, a use case, but in general, that's enterprise is generally a private blockchain. Hyperledger Fabric is one of those projects under the Hyperledger umbrella. So it is a permissioned platform, and I'll cover what permission means, and that's a big distinction for enterprise-grade blockchain architectures. So it is modular by design and has some standard components that are developed by this open source community. It includes ledgers, smart contracts, protocols, and so forth. And it is typically built with a standard set of languages around how those smart contracts are done, for instance, or what ledger solution we would use, or which ledger database you would use underneath. As I said, governance is through the Linux Foundation and open source developers, of which IBM is a major contributor. Now, IBM has a very long provenance when it comes to blockchain. It is an evolution of what we've been doing with our financial services clients and other industry clients that require some sort of streamlining and traceability and transparency of business-to-business transactions and inter-business transactions. But it all started specifically in blockchain around August 2015, where the first terminology around and technology around open blockchain was developed, and IBM started its first client engagements. Within 6 months or so, IBM became a founding member of the Linux Foundation for Hyperledger, and it still to date donates code and IP specifically to try and promote further development of Hyperledger and Hyperledger Fabric. And about 6 months later, again, we had blockchain garages, and the first version of the Hyperledger Fabric, version 0.6, was released for public use. And Fabric 1 was released in June, so about a year later. And I think it was about a couple of months later, August timeframe, that IBM developed its own enterprise supported version of Fabric called the IBM Blockchain Platform. So there's a major difference there in that it takes what Fabric does, what Hyperledger Fabric, which is the open source version, is, and adds to that some additional IBM software stacks like MQ and other capabilities to try and develop a more holistic way of delivering blockchain as a capability. One of the use cases that we first deployed and is now generally available and was released in 2018 that was built on blockchain, specifically on IBM blockchain platform, was IBM Food Trust. And I do have a slide on that at the end of this. If we can get to it, we will. But it is generally available for someone to look up if that is of interest. It is basically a blockchain for tracing from farm to plate any food products that are used by major manufacturers and stuff. That's primarily used in the in the US, but it is also generally available in other places as well. So to date, we are still developing blockchain, and we're still developing the platform as well as contributing to the actual community. So key differentiators of Hyperledger Fabric. As I said, it is a permissioned ledger. What that means is the users must be authorized to participate, and the visibility is limited to those of those particular transactions of those who are actually involved in that transaction. So in other words, just because you're part of a blockchain network does not mean you get to see all the transactions that occur there. Unless you're actually a participant there, you need to actually sign off on something, or you're actually a receiver or a sender of some asset. You don't necessarily need to be able to see it. And that level of privacy is included in the idea of a permission ledger. It also means someone who's not authorized does not have access. And there's very specific mechanisms that are built in Hyperledger Fabric around how that is controlled. And we'll do more of a deep dive on that probably in another session. It is a modular design, as I said earlier. It is very much component based, so you can choose what you need. If you don't need, for instance, the database component of it, the Hyperledger, the ledger itself, or if you want to use a different one, you can actually, for instance, bring in your own consensus mechanism because you want to build your own IP around how consensus works for one of your use cases. You can do that. And there are, as I said, multiple ledger formats, and there's a Kafka algorithm that is available natively for consensus that is actually can be leveraged, or you can build your own. So one of the key advantages of how flexible it is the fact that it therefore suits different industries and different use cases in those same industries. It is not just for financial services, but as I said, food trust in fast-moving goods in that space, for instance, uses Hyperledger Fabric. And similarly, we have other ones around identity management and so forth. High efficiency and scalability. One of the key capabilities is the fact that because it's a smaller number of authorized participants, and you can control those participants, and you can scale your network based on who you're adding and when you're adding them. You can actually control how many nodes are there processing what they need. Also, the processing of different things, everything from acknowledgements to automated contract settlements. All of that is done on independent nodes in parallel, can be done in independent nodes and in parallel, which means there's a lot higher efficiency in terms of how quickly transactions can be closed. And typically it's rated at least 2,000 transactions per second in general. You probably see that in many use cases being higher than that. There is no default or mandatory cryptocurrency or charging mechanism. That is important to differentiate between that and one of the other popular ones I'll cover in a minute. Alternatives for Fabric. And that means that you don't actually necessarily need to use a cryptocurrency or need to have a cryptocurrency wallet or a way to pay for it through cryptocurrencies in order to participate or to build a blockchain network with Hyperledger Fabric. And that means that that's one of the reasons why you could use it for different use cases, for instance. Smart contracts, which basically means is an automated way of settling what is a traditional way of doing certain things. So if you know this is how you buy something and someone buys it, you don't need to keep validating everything if you know who the participants are and you trust them to a degree. So if, for example, if someone is sending $100 to somebody and you know that they are who they say they are in terms of who's receiving it and who the sender is, the second time they send $100 around, you can automate that transaction, or you can speed it up. That's a very basic example of what a smart contract would do. So in Hyperledger Fabric that is known as a chain code. And chain codes can be written in Golang or Java or Node.js, which is more of my favorite. Okay, alternative one, a more common one that people will talk about, that you will hear about, is Ethereum. Ethereum is its own ledger fabric that has been developed by the Ethereum Corporation, I think they're called. But in general, they're their own developers, and they're actually they actually support this. So in some ways, even though anyone can develop with Ethereum, in terms of build a capability, it is very much a controlled set of things. It's not true open source in that respect. That's just my point of view, but there are components of it that are built by the Ethereum developers, and how they build it is how you're meant to use it. The biggest differentiator here is two. One is it's a permissionless ledger. It is designed for public blockchain networks, and that means anyone on that network can see any transactions that go through. So you don't necessarily need to be somebody who's part of that transaction between person A and person B to see that person A sent something to some person B. It is you could say Ethereum's documentation, for instance, asserts that security is improved because of that transparency. It means that it's hard to corrupt. Since all participants have a distributed copy of the ledger, it does, however, compromise privacy, because it means that two people can't do something in private and move something pretty heavy. Hello? Oh, sorry. Okay, I thought that was a question, but all right, I'll continue. So yes, so as I said, so you're giving up a little bit of privacy for a little bit more transparency. That's kind of the message there. It is less configurable, as I said, because it is designed by the Ethereum developers and is designed to work a particular way. And in terms of scalability and efficiency, it is lower than Hyperledger Fabric. It is typically rated around 20 transactions per second, because there is a smaller number of nodes performing a large number of public transactions. Because anyone can jump on anytime, it's a little hard to estimate, it's a little hard to plan for and scale, and so it doesn't scale as well. As I said, there are two key differentiators. One was the permissionless nature of the ledger. The other is the fact that it is a mandatory Ether cryptocurrency requirement. And there's a charging mechanism for using for every transaction called gas. And you buy gas in order to execute a transaction with the Ethereum's cryptocurrency called Ether. So you have to have that in order to actually participate in their blockchain network. Now, smart contracts as a concept was first developed for Ethereum. And it uses Solidity, which is a different programming language. That's just for anyone who's interested. And as I said, governance and support is entirely from the Ethereum developers themselves. So if there is something that needs to be done, you work through the Ethereum group. Another alternative I will cover today briefly is Corda. Now, Corda is the other permissioned ledger. The reason I'm including it here is because I wanted to show one where there's more than one option, right? So in terms of a permissioned ledger, Corda also runs on the IBM platform if it needs to. It's not an issue. We work with everyone. As a permissioned ledger, it is slightly different in terms of its origin. It is very much focused, at least initially anyway, up until now, around financial services, and more importantly, again, more focused specifically on compliance with financial industry requirements and judicial process. So their idea is a single contract, which combines both the business logic and the data required to execute a transaction. And as part of that, it actually includes the compliance process as well. It also offers things like pluggable notaries for particular transactions, where a notary may be required for large transactions or for security of those transactions that are those assets that are being pushed around. But because of that, it is less configurable and flexible than HLF. It is, as I said, very specifically designed by for particular use cases, in this instance, financial services, but it is slowly extending out by trying to be a bit more flexible in that space. It is open source, so anyone can take Corda's capability and build something else, but it does have certain limitations around governance and support. It is designed and supported by R3. It's an organization and their professional services currently is limited only to the Corda Enterprise subscription of Corda itself. So there is a general or a public version of it, a community edition, if you like, but that's not supported by professional services from R3. But you can do a lot more things with the, I guess, the open source version if you wanted to build your own capabilities. And that is one of the reasons I've done that, is because they want to try and extend beyond financial services if they can. So that's in progress. Efficiency and scalability are subject to the architecture. So as I said, it depends on how many notaries, how big the workflow is, what the actual transactions are. There are also some availability and operational functionality still being worked on, like high availability for particular components or processes or steps, as well as rolling upgrades are still being worked on for, changes to the ledger or upgrades to the ledger fabric or upgrades to the compliance business logic, for instance. And again, similar to Hyperledger Fabric, there are no mandatory or default cryptocurrency requirements, but you can again plug in what you need if you need to be able to move them around. Okay, I'm going to step into what's called zero trust. Now, some of you may have heard of that term. It's an industry term that's growing in, I guess, in popularity, given what we're seeing today, especially even during COVID times, in terms of some of the compromises different organizations have faced, government and enterprise. And zero trust is based on, and the reason I'm including zero trust here is because one of the things, as I said, holding back the adoption of blockchain and adoption, especially in the digital asset space, and the growth of that market, especially in this region, is the fact that trust is still an issue. Some of the biggest scams and hacks that we see even today are very much related to the cryptocurrency space, and therefore there is an immediate, question around how safe is blockchain. So zero trust is what we need to make sure that we can actually deliver that on the promise of what blockchain actually offers us. And zero trust is built on true principles, and that is what is required to deliver true confidential computing. One, that external entities should not be trusted. It doesn't matter who they are, even if it's your cloud provider, you shouldn't trust them. And the more important part is internal internal entities, your own administrators and your own developers should also not be trusted. Not that they should not be trusted, but I probably should have written there, should not need to be trusted. So in other words, you need to have mechanisms in place, and security must be implemented from all the way through, from development through to deployment to operational management, whether you do it on-prem, do it yourself, buy it off, as a black box off a shelf, or run it in the cloud as a service. And that security needs to be pervasive all the way through. Some of the more common attack vectors we're seeing today, and hasn't changed, is in the last 10 years or so, is remote attacks. But the more recent ones are the last three. Remote attacks are basically hackers trying out different ways to get into your system, to take data and basically take over your system. Privilege escalation is where, just because you have access to one container or environment, that by default gives you access to another environment where you have no business being in. So as an example, is you are an administrator for your HR system, you have no business touching transactional systems. But the fact that you can get into one, if there's a loophole and that gives you access to the hosting layer, you can actually get to something else even in your own organization, which you shouldn't be able to. Insider attacks are unauthorized access from within to data, your keys, memory dumps, and so forth. Just someone running off with some disk with some data in it. That's as close as it needs to get. Image tampering is more important. It's a more prevalent one these days that we need to be worried about. And this is because there's a lot more modular development. There's a lot more open source development, and there's a lot more leveraging of open source codes and so forth available on GitHub and other places that you might want to use, or your developers choose to use as part of their application development strategy. The implication there is that there's the potential to either maliciously or accidentally insert backdoors or malware, and more importantly, inserting third-party code that shouldn't be that hasn't been vetted as part of your application deployment. So those are some of the, and today I'm just going to cover insider attacks and image tampering as part of the next steps. So what is the case for zero trust? It's very simple. The numbers on the screen kind of make it very self-evident. Data breaches in cybersecurity, they cost financial service losses up to 700 billion in the next 5 years. That's just an estimate by Accenture. And then you're talking global average cost of a data breach to organizations, of up to 3.92 million. That's per breach. And then you have complex regulations, so fines paid by banks between 2009 and 2017. Again, that's from BCG, Global Risk Organization. So that's an independent source as well. And it was $321 billion in fines. So these are not small numbers, and therefore there's an obvious case for zero trust. So what are the business needs specifically that zero trust needs to be addressed? That is meeting regulatory compliance is one, making sure you have complete authority over sensitive data and workloads, making sure no access, even to cloud providers, especially for sensitive confidential data, is possible, and ensuring data privacy in general for your end clients. And this is particularly something that stops people from moving, production or tier one or sensitive workloads into cloud today. There are reasons why banks are only very slowly looking at how to move, what to move into a hybrid cloud kind of architecture. But again, that's a discussion for another day. But this is one of those reasons. How do you take what you can do today on-prem, on your own, in your own data center? How do you take that and make sure that you get the same level of security in the cloud? So understanding insider threats, and here's again some more recent numbers actually. So 2020, Tesla, a disgruntled employee exported large amounts of high sensitive data to unknown third parties. So that could be pure IP that went to external manufacturers that could compete with them. Twitter, 130 accounts hacked. Now that's more obviously potentially more personal for someone who uses Twitter, but it could also have more corporate sort of implications where Twitter is used for those kind of purposes, and government in particular, for instance, in that space. Again, 60% of organizations had more than 20 incidents a year. That is not a small number. And as I said, the total average cost of an insider threat as assessed by the Ponemon Institute in 2020 was around 11.5 million. That's just an average cost. Now, even more recent one than that is the Target hack in the US, where they estimated around 50% of their customer data was stolen. And this was done actually by scraping malware directly through their point of sale devices. The cost to Target was significant. 110 million customers were exposed. The Target had to pay 18.5 million to settle the case that was then, those 110 million people obviously brought against them, and spent over 200 million in legal fees just on the ongoing settlement processes. The CEO obviously resigned, and in terms of the settlement, it was regulated or required that cardholder data needs to be completely isolated from the rest of the network. So that was something that should have been done in the beginning, but obviously hadn't been done. So how do you design for zero trust? The IBM approach, and certainly one that we see reflected in other organizations as well, and in the clients that we speak with, is the difference between what we call operational assurance and technical assurance. That is particularly important if you're going to do or build capabilities in cloud. Now, most cloud providers, for instance, will tell you that I will not access your data. So you have some sort of thing that says, if someone accidentally accessed your keys or accessed your data, guess what? You can move, you can leave. And there's some sort of, basically it's a promise, and that's all it is. What we're getting towards when it comes to zero trust is a technical assurance saying that it is actually not possible for me to access your data. Whether I'm the administrator or not, whether I have actual physical access to the machines on which your data runs in the cloud, I still can't get your data. That technical assurance is a central tenet that is required for delivering confidential computing in general. Now, confidential computing, in terms of a definition, let's look at what are the existing protections that we normally have, right? So one is, it talks about computing, it's about protecting data at rest, making sure that inactive data, whether it's been sent off onto a tape, into a backup or something, or just sitting there on a disk somewhere or a file server, cannot be accessed or transferred easily, or cannot be, or at least is encrypted. And if it is taken off, can't be used. Data in transit. This is more about public and private networks. When I move data from on my server up into Apple Cloud or whatever it may be, I want to know that that transaction or that particular transfer is encrypted. So that's in transit. But what we're getting at is the increasing focus is more about actively being accessed by an application or user, or stuff that's still stored in memory, where as part of the transaction. And that's everything from in-memory databases like SAP HANA, for instance, all the way through to other analytical engines that run in the cloud, in memory, or in general applications that use memory to store, transactional data as it's being processed. So confidential computing is about data in use. So it's basically everything. It needs to be able to protect everything that's, whether it's in memory, whether it's in use, whether it's being accessed by an application or a user. So how does IBM do it? So the IBM approach, the IBM systems approach in this place, is specifically around is about addressing two areas. You can't just address the hardware. You also have to address how applications are built, how images are deployed, especially these days when everything is containerized. Or more increasingly being containerized. From a platform perspective, as I said, we have what is called Zero Trust built into the platform in what we call IBM HyperProtect services. And we have 3 cloud offerings as well as on-prem. But in the cloud, we have 3 ways of doing that. One is we have virtual service called HyperProtect Virtual Service, which only the client has access to. And even the IBM cloud administrators can't actually get to the client app or your databases. So whether that's the virtual service where you choose to run your application or your database, or you can subscribe to the HyperProtect database services themselves. Currently that's Postgres and MongoDB, but there's probably more coming there. But in general, the idea is what you run in those secure service containers, which is what they are, you're the only one who have access to. We also deliver a virtual trusted key entry system to a crypto services offering that's built on our crypto service, crypto cards, which I will cover later. And that is where you can load your own keys, and you're the only one as the subscriber has access to the keys, with which you actually encrypt both your virtual servers and your database and your data. In other words, an administrator can change disks, they can add more storage, they can add more hardware security module crypto cards, they can swap out chips, they can swap out power supplies if that's what they need to do, but none of that will actually give them access to anything that is actually data or applications that are actually running within these virtual environments. It is fully FIPS 197 compliant, and it will deliver memory enclaves of up to 16 terabytes. The nearest equivalent on Amazon, I think, is about 192 meg, is the biggest enclave you could run there. That could be changing, so please don't quote me on that, but in general, ours would be the largest still today. And we deliver, as I said, both horizontal and vertical isolation. So between those application environments, those virtual servers, you have to physically enable access between that first VM you see there and the second one. And that is also encrypted. It's encrypted through an encrypted MPLS link. And it is rated at an EAL5 plus isolation, which is better than air-gapped, physical air-gapped servers. That is the level of security you get at the VM level. And pervasive encryption is available by default: network, memory logs, data in flight and at rest. So that's the systems, the server side of things taken care of. But what about the actual, how you build an application, how you deliver images and so forth? IBM has developed this capability called Secure Image Build. And that basically says when you develop something and then you want to build an image based on what you've developed as an application, you actually sign it with a private key. And then the corresponding public key is required on the virtual service, the HyperProtect virtual server environment, in order for you to push out any images, that you've built. What you do is you create the images and then you publish them with the encrypted key, public key, as part of the actual publishing process to Docker Content Trust. or the image cloud or the IBM Cloud Registry, and only those cryptographically signed images and the manifest can be used in order for standing up an application. So when you then need to do an update, you use exactly the same process. There's no way for someone to get in, halfway through that, update one of your images in Docker Content Trust and change it, because they won't have the relevant private keys in order to actually make any changes. You won't match the public key that is used to validate the image that then gets pushed out, and therefore it won't actually load. This is what we call the true secure DevOps approach for delivering, developing, and implementing and operating workloads for zero trust. It also has the option of adding third-party attestation for software or code. So you could add that between that step 1 and step 2, or part of step 1 and step 2 in parallel, where a third-party auditor of some sort can do random or spot checks or full code checks and actually add their signature to your manifest that you then push out into your Docker Content Trust. And without 2 sets of keys at that point, you won't actually be able to deliver an image and have it run in production. So what is, as I said, secure build? Very quickly, the value is trust, and it is tamper resistant because you need multiple signing keys, and you need the image signing keys can only exist inside the secure image build server and not accessible to users. So from there, it means that your image provenance is confirmed, and the image source and manifest files are encrypted as well, that you deploy into Content Trust, for instance. And application secrets are protected because even an administrator from IBM cannot actually look at what you've been running in there. A good example of this particular process that is going to be in use or already in use, and this was announced by Apple at WWDC in 2020, is that the SDK that Apple releases to its clients, to its developers for health apps, going forward will use secure build, which basically means that the end user of the application on your phone where your health records are there, even the developer cannot actually get access to it. So your health records are yours, and Apple and the developer of an app can't actually access your health records for privacy reasons. Now, how do we do this? And this is the last part of my presentation today, and that's specifically on HSMs. Now, there are different types of HSMs and different levels, and the levels are measured by FIPS 142-level 1 through to 4. Now, the IBM Crypto Express 7S is the only commercially available one that is level 4, and it is not only protected by the Germany development team that builds these things from temperature attacks and side channel attacks and probing or drilling. So physically taking a drill and drilling into HSM to try and break the encryption key or whatever, and try and get access to the keys that it holds. It even prevents proton beam attacks, like, and chemical attacks and voltage attacks. Now, voltage attacks, I don't know if anyone saw, but there was a vulnerability found at the end of, I think it was end of 2019 or early 2020 in the latest x86 chipsets used by pretty much everyone in the cloud, except obviously our particular HyperProtect footprint, where changing the voltage immediately started dumping out the keys that were stored in memory on the actual HSM. And that's publicly available information. You can look it up on Forbes or wherever else. So what does that actually do? So not only does it prevent those access, but if someone tries to access it, it's the only HSM that will immediately destroy the keys. It'll zero it out immediately upon tamper detection, and it will guarantee against loss to attackers. So the minute someone tries something, the keys are zeroed out, and the user is alerted, or the administrator of whoever owns the client is alerted, I should say. So as I said, the key differentiator here is at level 2, you get some level of physical security features around seals and so forth. So the cards themselves are actually, so the Gemini hot wallet is an example of a FIPS level 2 HSM for storing your crypto keys, if you like. But that is physical security to a degree. And then we can add things to, so what they do at AWS or Google, for instance, and Azure, the HSMs themselves have tamper protection on the covers and the doors themselves, so someone physically can't get to them. If they try, then they do have some level of, some level 3, for instance, also have key destruction at level 3 plus. So there is some level of protection, but level 4 is where you get complete 360-degree protection, and the response for us is very unique in terms of the response time, which is 100 nanoseconds, and error code correction as well. So those correct against potential CPU processing faults as well, if in case there are any that could be seen as a hack or something like that, but it actually isn't. So it does look for those things and prevents key loss in case of any processing issues. And yes, that little box on the left is an important one. These are some new things that are available in the 7S version of the HSM, which came out with our latest version of our LinuxONEs. And that is one, it is quantum safe. There is ongoing development in terms of ensuring that quantum computing for cracking codes and stuff like that. There is obviously a parallel work being done on making sure our HSMs can handle ways to prevent that. And the more recent SDK that's been released and that is being worked on is for different use cases is fully homomorphic encryption, and it is already fully FHE capable. And I will cover that in the next slide because that's an interesting domain for myself. Specifically, it talks about how do I share data with someone to do work, but without actually encrypting it. So FHE does not use scrambling of your data. It actually buries the data in a whole bunch of noise. And what that means is it enables AI and machine learning and big data analytics to access encrypted data without actually decrypting the data that it actually is working with. And that's an interesting space, and there's a lot of work being done in that space. There's a link there for anyone who's interested in what can be done. So quantum safe cryptography will give you some information on both of those capabilities of the HSM itself. And if there's an interest, I can even run another independent session on that particular, on the HSM itself and what we're doing in this space and quantum and so forth. And we can get guest speakers from our research labs to do more of a deep dive. But as I said, it's all about confidential processing of data without actually decrypting it. So that is already available as a capability out of the HSM that we actually have both in the cloud and on-prem. That's all I had really. So we'll jump into Q&A. I'm happy to take the questions now, or I can quickly run through a couple of use cases as well that we talked about around what we can do with blockchain.
Thanks very much, Anand. That was a brilliant presentation. I learned a lot actually about the IBM stack and the things you guys are working on that I had no idea about, specifically to do with FIPS 140-2 and the FHE side of things. Very, very interesting. Do we have any questions from the audience? If not, I've got a bunch.
Okay, there's someone who's raised an interest in the AI and quantum computing and secure access to data. So I think maybe we look at how we can organize a potential session around that. And Alexandra, you can, if you wish, you can actually reach out directly to me. My email is on the deck, and we'll publish that, won't we?
Yes, we can circulate that around. Yep. Yeah,
so that way, if anyone has any questions that comes up afterwards, I'm happy to take them as well and talk them through it.
Lovely. Well, I might kick off the first question. So my question is, so you mentioned Hyperledger Fabric is not the only Hyperledger service.
Yes.
Are you able to give us a brief on some others? Maybe go into some of the Greenhouse umbrella stack?
I don't have anything on the Greenhouse stack here, but as I said, the two I did cover were specifically Coda and Ethereum. Yes. And so it's horses for courses, right? So the idea of Hyperledger Fabric was designed for, how do we make it available and be useful in multiple use cases. So whether you're working in, and maybe that's a good way to get into it, whereas something like Corda was specifically addressing financial service requirements, right? So, it's an interesting thing. Okay, so this is one example, right? So where Corda or Ethereum wouldn't actually function. You need something that's a bit more generic, does not require certain things. So TradeLens, for instance, is one of IBM's deliveries on blockchain using Hyperledger Fabric. And this is where it's open and extensible, and it's for shipping events and messages and documents, where across the globe we can do, we have multiple participants in this blockchain network. Each of them have different requirements. So there is a shared ledger component, but it is more, if I was to get into it a bit more detail, it's more multiple side chains, basically. So, and in other words, customs guys, brokers talking to custom systems in different regions would be able to share specifically customs related information on, something that's being transported. Whereas the shipping manifest side of things was more around shippers and the actual supply chains themselves. Because the customs guys, brokers don't need to know what is in the box. They just need to know that it is what it says it is. So there's a circle of trust there by the fact that the participants are all validated. So as I said, because it's a permissioned blockchain, in order to be a shipper who's in the TradeLens, they have to actually have been authorized to be a participant. And the same thing goes for customs brokers in different countries and freight forwarders and so forth. So this is one use case where, and you will note no mention of any cryptocurrencies being used in anything in this. So it is entirely about visibility, but shared state for container shipments, but it is different levels of permissions. And that is, shown by the different types of arrows that you can see there. So some of it is a bit more granular, some of it is a bit more high level, but in general, it is fully auditable all the way through. From when something needs to be shipped, something's been picked up and is actually delivered, and then the entire thing can be audited depending on countries and where it went and so forth. Bottom line, all of this is executed with smart contracts, so it actually speeds up deliveries and and speeds up cross-border transactions, specifically in shipping.
Yeah, I've actually seen the TradeLens event list. There's something like 400 plus unique specific events that can be triggered, and the whole process is extremely granular and well thought out. So yeah, amazing achievement to be able to link it all together and have that level of transparency. It's brilliant. So we do have a question from. Oh, sorry, were you going to say something, Anand?
No, I was going to go into payments, but that's fine. So we do a similar thing with payments, but here we do streamlining for fiat payments. So this is, again, not for crypto, although it can be, but it is currently not used for that. But so this is about cross-border payments between different banks through what's called IBM WorldWire. And again, Hyperledger Fabric actually fits this a bit better because it can get rid of things like, intermediaries that need to do currency transactions and trades and so forth, and we can automate that entire process. And that's what we have done. So it's about the reduction in both the transaction costs and also the transaction time, and it improves liquidity for those participants in that network.
So a question on that, how does that relate to things like GDPR and SEPA transactions and those sorts of things?
All the more easier, because as rules for GDPR and so forth are actually evolve, those countries that are participating that need to actually do something, though their nodes need particular, or that particular subnetwork, for instance, needs a bit of work done, or shall we say, a release implemented there that's specific to that, it can then automatically also propagate to the network that it needs to, where the transactions are actually processing. So there's a more centralized way of delivering these things, and it can be done in flight. It actually, again, as I said, it's that overall operational efficiency of how many people have to touch these things to actually do this. Because it's automated, it can be tested and it can be streamlined, and it can be, pushed out as easily as these are the different participants for these countries. We need to actually add this particular rule set, for instance, and then it goes off to those new nodes that service those particular countries or those particular type of transactions.
Very nice. Very nice. Great use case.
Thank you.
We actually have a question here from Alexandra, which is, so what are the next challenges and can they be solved with AI?
Aha. Okay. So thankfully, I did a little stint before I jumped onto this whole digital currencies and blockchain bandwagon at IBM. I did a bit of work with AI. The challenges that we have here will be about predictability. One of what we have seen with COVID, for instance, is if I go back to the trade lens example, having the fantastic network that gives you that auditability is only takes you so far. When you run into physical, real world problems around transportation and people not being around and so forth, and limitations on what can be shipped and so forth, it does cause a certain level of difficulty. Now, AI can actually, the infusion of AI in that kind of situation around blockchain networks can actually help identify problems as they start cropping up. For example, a basic thing would be transaction turnaround times. If it starts seeing growth or unmatched or unpredictable growth, or shall we say, I'm looking for the right word here, but for instance, unexpected change or unexpected growth in transaction times, or how long it takes to actually add, just because you've added 20 more people or 20 more new things are being shipped. If that does not reflect correctly in terms of how long transactions are actually happening, then we know there's a potential issue there. Now, AI is more likely to find that a lot quicker, and especially with things like deep learning. And TensorFlow has some predictive algorithms around financial services for this sort of thing. There's a lot more research that needs to be done in that space to make it more effective. But I can certainly see the need for AI to actually blend with this particular thing, because really, when you think about what blockchain is, it's about us taking our existing processes and trying to make it more efficient. AI gives us the ability to say, is there a better way to actually do some of this stuff, especially now that we're automating it? And that for me is probably one of those use cases where in terms of finding operational efficiencies. The other is there is still, even in this particular architecture, no matter what you do, there's the potential for unexpected or unplanned risk around shall we say, bad actors, right? Just because you trusted a customs broker today and he's part of the network doesn't mean he's going to be a trusted actor 5 years from now, because at the end of the day, behind all of this is still people. So what we need, the work around fraud prevention with AI across this actually needs to will only help enhance the blockchain effectiveness of that network, right? So of the blockchain network. So for me, fraud prevention, RegTech, again, around compliance and automating some of the changes in GDPR, as you mentioned. If we can use AI to actually add what we need to add based on an analysis of what is already there, and minimize the turnaround time for things like RegTech, those are, I think, pretty good use cases. Yeah, very much so. Along the same lines there, just building on that last question, what would you say are the top 3 AI and blockchain use cases that first come to mind for you? Okay. I think certainly, as I said, there's a lot more work these days being done around RegTech. I think there's a lot more compliance requirements that our financial services, banking and sectors, for instance, are currently being faced with, and we need to be able to do that a lot more efficiently. And I think AI has a huge role to play there. And the other is, as I said, operational efficiencies and making sure that we add some, that we can reduce what is going to be, the larger the blockchain network, the more we, especially in a public blockchain where everyone can see everything and potentially has to do consensus or be party to consensus, and the ledger is very large, and even though it's distributed by the fact that it's across a very large network, it slows the network down. We need a way of reducing that transaction time, a way of streamlining that and making it more efficient, and AI is probably a way of doing that. It's probably the best way of doing that, of looking at what is the best way to limit or reduce some of that of those constraints. So this is where, when we talk about blockchain, we talk about, the difference between layer 2 and layer 1. So you have Ethereum at a layer 2 that sits on top and leverages what you build underneath at a layer 1 in terms of how an Ethereum transaction will take place. A crypto trade will happen. But what happens when there's 1 million or 20 million transactions happening in a day, and then you start seeing drops in efficiencies? What happens when if that particular blockchain trade network, multiple exchanges at a global level needs to participate, and therefore there's a lead time for transactions to be actually completed? Even with a smart contract, there are still authorizations and acknowledgements that need to happen at a global level. Now, if we can use AI to streamline how those happen at the layer 1 network, that will actually speed up and actually improve how many transactions we can process. So that's one. The other is healthcare. There's a lot more work we can do with healthcare with blockchain in terms of EMRs and patient records and so forth. And again, AI does have a pretty significant role there to play in terms of how do you match what needs to be done at the edge in terms of identification of particular threats and stuff like that. With COVID, for instance, where is this strain going? So today, this 20 minutes ago, I live in Melbourne, and we just gone into a snap lockdown for the whole state, because there is no way to predict where those, the people from the 1,000 people at Melbourne at the MCG went. Now, AI, with its modeling capabilities, if we can apply that here, we would have a much better way of tracking that, and then having the track and trace capability built on a blockchain network will mean that we can actually respond a lot quicker. So those are the sort of use cases I see that are more important these days. So they kind of have to work hand in hand. They each have different functions, but there's that synergy there with what we can achieve with AI today and what we can achieve tomorrow, with what we can then extend in terms of use cases of blockchain.
Lovely. So I have one more last question, which is more for the audience benefit, which is, how does someone start to get involved with blockchain, and what advice would you have for them?
Yeah, look, there is probably multiple resources for understanding what blockchain is. And it depends on where you fit in. If you're a developer and you want to learn how to develop, I would definitely start with an open source platform like Hyperledger Fabric, because it has multiple languages that you might be comfortable. As I said, I kind of lean more away from Go and probably towards something else, but there are multiple ways of comfort levels. You can use Java if you want, and that sort of thing. So if you're a developer, you have different ways depending on your comfort level where you want to start in terms of getting your hands dirty. The only way to learn this stuff is to actually get your hands dirty and do some work, and build your own little Hyperledger Fabric network of some sort, and you can test these things out. You can even build your own demo wallets and have pretend trades and stuff like that between them. Now, you can also get in touch with us if you're interested in testing out our secure build process, where we actually have an active demo you can participate in. It goes for about 3.5 hours, where you actually build your own secure build server, and you can actually build your own digital wallet, and you can try and load an image that you have not signed and then see how it fails, and then load an image that you have signed that you will load. So there are things you can do that we try to do. And there are also online courses for everything from learning about blockchain to developing for blockchain and developing with Hyperledger. And there are similar ones for Coda and others. But in general, the best ones are Hyperledger Fabric because it's open source and it is Red Hat Foundation. So everything is out there in online. But if you can't find it, please reach out and we can certainly point you in the right direction.
Wonderful. Well, that's a brilliant wrap there at the end. So on behalf of IEEE, I'd like to thank you very much for your presentation this evening, Anand, and for lending us your time and knowledge and resources. And to the whole IBM team, thanks very much.
Thank you.
And any closing remarks or thoughts?
There is one other slide that I forgot to add, but I will add to the deck before I send it to you. And that is, it's not just for making money, and it's not just for, and that's one of the reasons I got into this space. So one of the clients that I presented with in 2018 was the Plastic Bank, and you can look them up. So they developed a blockchain-based network specifically for addressing ocean plastic. So what they do is they created a stable coin that they use on their blockchain network to reward the poorest people in places like Honduras and other countries who live near the ocean and can actually go and recycle all the ocean plastic that they find. That stable coin that they have can be used and directly translates into fiat currency that they can then now, for the first time, they can have bank accounts. They can actually fund things for their kids, send them to school, buy books for them, and get healthcare and so forth. And this is something that they've been developing across Haiti and Honduras and a whole bunch of other countries, and they're still growing. The interesting thing is they're not a not-for-profit organization. They're actually for-profit, but they're not investor funded. They're actually funded by, once the plastic has been received at the plastic bank collection sites, they get sold to plastic recyclers like Coca-Cola and others, and they get 10 cents on the bottle that they actually recycle, or, per kilo or whatever it is. So there's a certain known value. Now, the blockchain makes, the fact that they use blockchain and Hyperledger and a shared ledger and a distributed ledger makes it easy for auditability, but it also makes it transparent. So everyone sees where the plastic came from. It says, here's how much the actual entrepreneur now that they are actually made by recycling this much plastic. And this is what became of that plastic. So Cotton On in this country, for instance, if you go and buy some of their t-shirts now, tells you this used to be a plastic bottle.
Wow.
So that, for example, is only possible because that information is available through a blockchain network. So we can actually change the world with blockchain. That's one of the reasons why I got into this after spending some time in AI and so forth. But that's what drives me every day, what makes me get up in the morning. So there's a lot of things we can do. We just need to have the imagination to do it.
Sounds great. Well, thanks again very much for your time, Anand, and look forward to some amazing things coming out of your side there with the team at IBM LinuxONE. And stay tuned, guys, because this is the first of several events that we'll be doing with IBM. So excited for the next one coming up in the future. And thanks everyone for attending and joining the presentation today.
Thank you, guys.
Thanks very much.